are doing is a recap. Okay, recap about what? Recap about these few things that you need to remember. So what is that thing you need to remember? Let me highlight and show you. The first one is actually sine. Tangent is sine over cosine. The second one, cotangent is cosine over sine. Don't bother about 1 over tangent because we hardly use this, but use this. But why is it this? Is because 1 over tangent. So 1, 2, but other than these two, right, you also have to remember cosecant is 1 over sine. Secant is 1 over cosine.
From 1 over sine, how to convert to
I will show you. I will show you. I'll show you in the example below. But can you first copy these two down and write down this one must remember. Remember means it is not given in exam. So this is not given. So in red color, not given, not given in exam. Right. Then the new one, these three I'm going to tell you is these three are given in exam. So you label them properly 1, 2, and 3. So later on when I call, I will say, which formula do you use? You use 1, 2, or 3. Okay. Now what does 1 means? This one means when I press calculator, go to the calculator, you press bracket sine 30 square, close, bracket sine 30 close square, plus bracket cosine 30 close square equals to uh, close square equals to what? And this angle can be any angle one. You try 29 also same. You try 58 also same. You try 99 also same. As long as both angles are the same, it is always equals to 1. And that is why this is called identity. Identity means I don't care what the angle is, it is always true. Okay? Now, but then I will show you how to use this later. But let's go through the first example. Let's have sine A bracket cotangent plus tangent A. Then what they want? They want simplify, right? Now simplify means they want to actually remove all the bracket. I want to remove brackets and basically I want to simplify it lah. Simplify as simple as possible. So step number one is a hint you can use is always to change everything to sine and cosine. Why? Sine and cosine is called the basic unit of trigo. So once I have sine and cosine, I can start to cancel if it's the same. Okay, that is why sine A nothing to do, so I just be sine A, right? But tangent I can convert to cosine over sine, right? And tangent I can convert to sine over cosine. So this is where you circle wrongly. You must circle cotangent A, cannot circle cotangent. Because the angle and the thing always go together. Alright? So now we are stuck in this step. Then what's next? Now look at it. I got two fractions. So maybe what I can do, I can combine these two into one fraction. I pause the screen now on the paper. Now I will use highlighter to help us focus. Next, what I want to show you is I want to show you cosine A times cosine A actually equals to cosine square A. This is the way we write. But actually you ask what is cosine square A, it's nothing more than just cosine A and then the whole thing square. Okay? So misconception is, hey teacher, when I take cosine and cosine A, is there such thing as cosine A square? Does the angle square? The answer is no. So it's not equals to cosine, the angle cannot square. So it's cosine square A full stop. Just like that. Okay. Now then we are back at this question here. So we are stuck at here, right? Yeah. Then you ask yourself, what's next? Then you can combine them together, right? So this is like cosine square plus sine square, right? Then you ask yourself, cosine square plus sine square is actually equals to what? Is 1, right? Oh, so done already. So I can convert to 1. Why? Because I use formula number 1. I use formula number 1, right? Formula number 1 says sine square plus cosine square equals to 1, right? So sine square equals to 1. After that, what do I do? Oh, I know that if there's a fraction, right, I can cancel the sine A and sine A away. So I'm left with 1 over cosine A,
Wait.
right? Yeah, so then what's the final answer? Then look at 1 over cosine A. I recall again, 1 over cosine A is actually this one, is secant A. So the answer is secant A.
Where is it?
This one. 1 over cosine A is secant A, right? So this is secant A.
If I left it in like the fraction, is it?
Not wrong actually, but this is a better answer lah. Okay, so we just leave it like that. Okay. Now let's look at the second one. Now I have something like that. Sine square then bracket then this. So it's very important whenever you see the one, whenever you see the one as in the one sticking out by itself, uh, you try and apply the given identity. So when you see the one, apply the given identity. So let's spot. Let's do forehand. So I look at three identity here. One plus tangent square look like which one? One, two, or three?
3.
Three, right? This one looks exactly like three. This one is like formula
So
three like
it
that.
means that it
So formula three means one plus tangent square straight away become secant
secant
square. So can you write down secant square? Over here, over here, when I have secant square, I don't look at this anymore. I don't look at this. The reason is because this one itself must have the one, then I will start to look at it. This one itself is by itself already. So there's no need to look at 1, 2, or 3. So what do you look at? You look at this. One, no, you look at this. Secant theta, no, sorry. Secant x is equals to 1 over cosine x. Then what about secant square x? Will be 1 over cosine square x, like that. So you use this to convert. You use this to convert.
But how this one? How you get 1
Oh,
over
this one is given. This one is the one that you need to remember. Let's look up again. This is the one you need to remember. See the yellow thing?
Sine x equals to 1 over cosine x. Sine square x equals
Secant
to
square.
but
Secant,
here's sine.
no. See? Since secant x is equals to 1 over cosine x,
Oh, this
secant
x
square is 1 over
x.
cosine square. So square both sides, like square both sides. Like that. Look at what I read. Look at what I read. If secant x is 1 over
Wait,
cosine x, you take a few. There are 3 stacks there.
so I just take the 3 lah.
I will give you tomorrow as well if you are doing tomorrow. Please put all the water there. To make things difficult.
Okay. Where?
There. You also have Piang eh. What are you doing? Yeah. Just don't take it to the library lah. Now,
Okay.
so where are we? Okay, so do you understand this part?
Yeah.
Okay, so now I have this. I convert to this. Then I ask myself, what do I do next?
Times.
This is like a fraction, so you can convert this into something like that. Because this is on top, this is below. Then sine over cosine is tangent. So sine square over cosine square, tangent square. So then you write your answer like that.
Wait.
Okay, then you try the third one.
How you know sine square over cosine square
Is tangent.
equals to tangent,
You have to remember,
which is here,
which is here.
which is tangent square x, because here got square.
Yes.
But if one no square leh,
Then cannot.
there is this.
Then cannot. So let me give you an example. If let's say I have sine square x over cosine x, then what happen? This is just sine x times sine x, right?
Yes.
Then over
Oh,
cosine
so
x,
it
right?
means that you can write tangent
Then this is tangent x,
x.
then sine x.
Oh.
Because this combine to give you tangent. Then this is by itself.
Yeah.
Like that lah.
Then where would this the cosine this one go?
No, sine over cosine is tangent. Sine over cosine is tangent.
So if you really take out the cosine, then you can then there's
No,
no
no
more.
take out. Sine over cosine become tangent. So it become tangent. So this is sine over cosine. This is sine over cosine. It become tangent. Full stop. Do you follow?
Then after that, then this one is by
This
itself.
one by itself. I'm gonna copy down. So try number 3 now. Now, when you look at the top, look at the top. The cosecant square, you go and search. Is it 1, 2, or 3? Can you tell me? 1, 2, or 3? 2, So you see, I write that. 2. 1 plus cotangent square x is equals to cosecant square x, right? Right? Then after that, I ask myself, this is cosecant square x, right? So this is cosecant square x, right? Oh, that means I replace this into this. Do you understand? No. Again, this is given on top, right? This is the on top one, right? Then after I ask myself, cosecant square. Cosecant square, where is it? It's already by itself. So what it means, I can replace this with this.
But
I
you
will
cannot.
replace this with
Why
this.
you don't want to just move this here, move that here, then
Also
this
can,
equals.
also can. And some of you like it this way. Some of you like it to tell me, teacher, can
Isn't
I
it like more words if you put
can I
like
write it
one
this way?
less?
Or they can just directly write that.
Then
Yeah.
this one can put inside.
Yeah.
But notice when this one put inside, your answer is minus tangent square. Look at the answer.
It's not plus. Eh?
No, because you move this over, you move this over, you also move this over. Like. So the difficult part is to visualize this, right? There's a lot of moving around. And when you move around, sometimes you forgot. But when you do this, it's also a tricky part because minus and plus will give you minus. So anyhow, your numerator must have minus cotangent theta. And 1 minus 1 will give you 0. So what's the idea here uh, behind the using identity is when you use identity, you realize that on top of two terms. After I use identity, it will reduce to one term because the 1 got removed.
Where got two terms?
Eh? 1 minus cosecant is two term. 1 minus cosecant. Terms are separate by plus and minus.
Yeah.
So I have two terms already. But over here, once I extend out, I realize that 1 minus 1 is 0. So I'm left with one term only. Can follow?
Yeah.
Okay. Now this
Also,
is done.
you still get negative cosine. I mean cosecant square x.
No, negative cotangent square x. Because you replace, remember you replace? You replace
Yeah.
the cosecant with 1 plus cotangent.
Mm,
So after you replace, what happened? You expand this 1 minus 1. You expand this minus cotangent square.
yeah.
Right? So 1 minus 1 is 0, you left this.
Okay.
Now what about below? Below then you have to recall this. What is a plus b? A minus b. What?
A plus A square minus B square.
And you must know this is the same as a minus b, a plus b. So it's the same thing. So knowing they are the same, then we can now start doing this. So this is actually equals to 1 minus sine square. 1 square minus sine square. Then 1 square minus sine square, then I'll ask you now to use the